first warm up here, number 1. Cross multiply. 6 times x is 6x equals 8 times 4 is 32. Divide by 6, divide by 6. X equals 32 over 6. Okay, now this is reducible because they're both even. Yeah, so I'm gonna go divide by 2. What's wrong, honey? You okay?
Yeah.
Okay. Divide by 2, 16 over 30. Okay, number 3. This one says find each product. It's a binomial times a binomial, which needs a box. This box thing, by the way, never goes away. Let me show you something interesting from the warm-ups from today's Math 3 class. Oh, look. Boxes. Oh, look. Boxes. Boxes everywhere. It never goes away. You need to be able to master the box. Okay. 8m minus 4. 4m minus 7. Okay, 8m times 4m is 32m squared. 4m times negative 4 is negative 16m. Negative 7 times 8m is negative 56m. And negative 7 times negative 4 is positive 28. Okay, these two are like terms as they usually are. So I have 32m squared, and then what's negative 56 plus negative 16? Negative 72? Okay. Minus 72m plus 28. Any questions about either of those two warm-ups? Are they good? Anything? Good. Okay. All right. Do not put the packet away. We are doing a resource page in it today, but that's not the majority of what we're doing today. Mostly it's in the notebook. Okay, we have 5 classwork problems, and there's going to be shape drawing. So just prepare yourself for shape drawing. Number 3 is the one with the resource page. That one will be very quick, but the other ones we have to spend a little bit of time on. And this is a little bit weird, but this is what we wanted to do. Tonight's homework, be very, very diligent. Tonight's homework is a digital escape. The homework is a digital escape. It is a similar figures digital escape. If we finish the classwork in time, which we probably will, I'll show you how to get started on the first one. And my joke says, no, you don't have to show your work. Go ahead and just circle answers, said no math teacher ever. Which is true. True statement there. Okay. All righty. Here is your first thing to draw. Now, this does not have to be perfect. Just because your teacher is a giant nerd pants and made hers perfect doesn't mean yours needs to be perfect. It is okay. Okay, let's talk about a couple of things. First of all, do you know what kind of a shape this is? It's a pentagon. It's a pentagon because it has 5 sides and 5 is pent. Um, and it has a name. Its name is Pentagon ABCDE. When a shape is named, it's usually with capital letters and it goes kind of around in a circle. So ABCDE. Okay. Do you see that the original pentagon is bigger than the new pentagon? Everybody see that the original one is bigger than the new one. Okay. So I have written a statement here. This is called a similarity statement. The similarity statement does two things. It lines up the letters for you. So it says, okay, A is in the front and M is in the front. So A and M are in the same spot in the pentagon. And B goes with N, and C goes with P, and D goes with Q, and E goes with R. Does that make sense? You see how this one's like rotated? Okay. It also says this little squiggle here, this little squiggle means similar, which means that they're proportional to each other. So do you remember the proportions we did for on our worksheets? Cross multiplying proportions? Do you remember them? We did one on our warm-ups just now, this guy. Okay, that means that you can find the sides by setting up one of these. Okay, now because I'm a visual person, I'm gonna take a red pen and I'm gonna mark the base of this one and the base of this one just for a visual ability to line it up. Okay, now this is notes, which means we're gonna do two things. We're gonna find scale factor and we're gonna find the missing sides. Okay, first, scale factor has a formula, new over original. What you need to do is find two sides, one in the new figure and one in the original figure that are actually labeled with numbers. Do you see the two that I marked with red? Okay, so this one is 10 and this one's 25. So you write 10 is the new and 25 is the original. I could have also done 14 over 35, by the way. And then you reduce. So what does 10 over 25 reduce to? 2/5. Yeah. So divide by 5, divide by 5. Okay, so the scale factor is 2/5. That means that this little guy is 2/5 the size of the big guy. Okay, so sometimes you're asked to find the scale factor. Sometimes you're asked to set up a proportion and solve. So let's find x. Okay, x is over here. Do you see x? Okay, x. Okay, what side goes with x on the big pentagon? B to C, right? 17.5. Do you guys see that x and 17.5 go together? Okay, so I'm going to say x over 17.5 equals, and then I'm going to use my scale factor, new over original. So I did new over original equals new over original. Okay, now cross multiply. 5x equals okay, so that means this side is 7. Okay, let me ask you some questions. Do you see Y up there? Can you find Y? Okay, is Y on the new shape or the original shape? New. Okay, and it might help you out to do this. You can tell with the arrow that this is the new, but just in case, might help with this. Okay, so since Y is on the new, we're going to put Y on the top, new over. And what side does Y go with in the original figure? Right, over here, 25 equals new over original. Cross multiply. Z, okay. Now, excellent. Z is on the bottom this time. Do you guys see why it's on the bottom? Do you see that Z is in the original shape? And original is on the bottom, new over original. What side lines up with Z in the new shape? 8. New over original equals new over original. Okay. And 2Z equals 40. Z equals 20. I'm pretty sure that this was 8th grade in the CPM book last year, but not a lot of it, right? I think it was just a little bit. Does anyone have any questions about number 1? Go ahead. Are you sure? Yeah. You're totally okay. All right. Not totally okay? Okay. All right, now let's move to number 2. Okay, now this one is spicy, guys. Prepare for the spice. The thing that makes it spicy is the fact that they're overlapping each other. And so it's kind of hard to see. So what I suggest is that we make sketches of them separately. We don't always have to do this, but on this particular problem, I think it really helps to draw them separately. Yes, I know it's a pain. I've been drawing stuff all day today. It's that time of year. Okay, how long is this little side right here? Hmm? 11.2. Hold on, let me zoom in for standard. There you go. Okay, how long is this little side right here? X. Okay, this is why we're doing this. Okay, how long is this side right here? M. Okay, now spicier question. Not so much right now, but how long is this bottom part right here? 28. Okay, now we're going to get to spicy questions. How long is this? Yes, I'm going to write X plus 27. So think about like if you have something that you measure and then something else that you measure, and when you stick them together, you add their two measurements together. Okay, knowing that, how long is this? M plus P. Okay, that's the first spicy part. Now, I'm going to set up a proportion with the height and the base and the height and the base. Okay, so new over original equals new over original. So I went right over left equals right over left. Do you have to do it that way? No, I could do x over x plus 27 equals 11.2 over 28. That give me the same answer. You know what else would get me the same answer? X over 11.2 equals x plus 27 over 28. Just as long as you're going in the same order consistently each time, you'll get the same answer. Okay, now cross multiply. 11.2 times x plus 27 equals 28x. You're like, oh, Mrs. Talbot, I understand why you reviewed this stuff before we did it. 302. Okay, what should I undo? Mm-hmm. Okay. Now I'm going to go back in and fill in the stuff that I know. I know this is 18 now. And I know this is 18 plus 27, which is 45. Do I know everything about the triangles now? No. What do I still need? M and P. Okay, just look at this one only. How do I get M from a right triangle like this? It's called Pythagorean theorem. Let's call it the right thing. Remember? That's supposed to be an N though. Okay, so remember what I said on Friday. It doesn't matter which ones are A and B, it just matters that the hypotenuse is C. Twenty-one point two. Okay. Anyone have any ideas on how we can get P? We need to get P still. We know this side, this whole thing, and we know everything about this one except for we know this one's 21.2 plus P.
A squared plus B squared equals 60.
We can't. Okay. Now, if we do that, what we're going to do is we're going to do 28 squared plus 45 squared. And I'm just going to leave it C squared because this is kind of complicated. Does that make sense? We could totally do that. Stan, you have another idea? Oh, yeah. Okay. So come over here. 28 squared plus 45 squared equals C squared. Does that make sense so far?
Yeah.
Okay, so now we're gonna do, let me show you what I'm trying to say here. 28 squared plus 45 squared. Okay, so then I'm gonna say 21.2 plus P equals 53 because that's what I got for C.
And just minus.
Yep.
C.
I did want to say though, if you didn't think of Pythagorean theorem like Rowan did, then you could have done 21.2 plus P over 21.2 equals 28 over 11.2 and did a proportion and cross multiply. You might have liked that better. It might have been easier. But if you think to do Pythagorean theorem, go for it. It works. That's kind of a spicy meatball right there. Okay, now after you have all this written down, if you could find the resource page that has the shapes on it. Actually, there's a lot of resource pages that have shapes. But it's the one that says 7.1.1 resource page at the top, and it's got shapes. I'll give you guys a piece of tracing paper per group. And what I want you to do with this resource page is in your groups. Go ahead, go ahead. What I want you to do in your groups is to figure out which shapes are congruent to each other. Congruent means exactly the same shape and size. Okay, so you're going to look at the resource page and find pairs of shapes that are congruent to each other in your groups, please. You can color them. You can just write down who goes with who. Just write on the resource page, please. So congruent, not similar, congruent, meaning exactly the same. No, there's only a couple of pairs. Yes. I think I see 4 sets. Okay, up here I wrote a list of 4. I think I see 4.
I think you have all of them. No,
Same shape and size.
and size.
Yeah, exactly the same as each other.
Oh,
Not same shape and smaller like we did in the previous one. This is same shape and size.
in each day.
Like none of them are.
So starting you off, E and H are the same. E and H are exactly the same shape and size. They're just what? Yep, G and L. K and F. And one more. B and D. Okay, now we're not done with the resource page. Next question is, what transformation do you have to do to get from E to H? I'm looking for reflection, rotation, translation. This probably needs. Okay, I'm going to say for E and H, reflection and translation. What I mean by that is if I flip H over and then slide it over here. Do you see that it's a flip and a slide? So take H, flip it, slide it.
Well, I mean, if you just flip it from like the very
It
middle, you
depends.
don't need
It
to-
depends. It depends. It depends on where you flip it from.
I mean, since it's both the same thing but reflected, if you just put.
You'd
if you
have to
take-
say midpoint between E
Yeah,
and H. You could say
if you
that.
reflected by then you don't have to. change
Correct.
it.
Okay. G and L. Rotation and translation, unless you want to identify a very specific point of rotation, that you could probably get from here to here, but we're just going to say rotation and translation. It's easier to say when they're on the coordinate plane. Okay, now K and F. It's actually all three the way I see it, but you could get away with just reflection and rotation, but it needs to be both of those. Is this just rotation and translation? Yeah. Okay, now we're done with this resource page and you can put that away. Okay, so this is what I'm gonna do. I have this up here in blue. Anything that I add to the diagrams, I'm gonna do in red so that you can see that it was actually calculated after the fact. And this was all the stuff given to you. Okay, so number 4 is asking a question. Are these triangles congruent? That means exactly the same shape and size. And you can't look at the graph paper squares. That's cheating. You have to look at the things that are labeled. Okay, so what we're gonna have to do is figure stuff out to decide whether or not they're exactly the same. Now, your favorite thing seems to be finding sides of right triangles at the moment. Can I find C here? Is that something I can calculate? Yes, okay. And what theorem would I use to calculate C? Yes, Pythagorean theorem. Pythagorean theorem. Pythagoras is a guy, by the way, 16 squared plus 63 squared equals C squared. Pythagoras was a cult leader, believe it or not. He actually didn't come up with the Pythagorean theorem. One of his assistants did, but he took credit for it. The Pythagoreans were a very weird group of people. They would allow women to sit with them, but they couldn't speak. They wouldn't eat beans. They wouldn't pick up anything that had fallen. They thought it was cursed after it fell. Their star was actually the pentagram, like a lot of cults. Yeah. Yeah. So anyway, 16 squared plus 63 squared is 4225.
It's like, you know, like, okay, actually, it's a spiral and it's like on the internet. It's like this.
Oh, yeah, yeah.
Is that it?
Yeah. That's called the golden ratio.
Yeah. Can't feel my other side.
Oh, yeah, 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 yeah. There's also a bunch of stuff on in the movie, the Leonardo da Vinci movie, with the guy and the painting and the what is it? Oh, so good. Okay, anyway. All right. So I got C is 65. Okay, so I'm gonna put equals 65. Okay, if the hypotenuse is 65 and the base is 16, and the hypotenuse is 65 and the base is 16, what does this have to be then? 63. Okay, so we're on to something here. You see, I'm filling in the puzzle. Okay, now, can I figure out what the third angle is in a triangle? 180 minus 90 minus 75.75. What is that movie called? He's with the girl and her grandfather dies in the beginning, and he's like the Louvre Museum, and there's the pyramid and the yeah, Leonardo da Vinci movie, like oh. It's a book. Mate, no, what? Anyone? Oh, no, it was make, I don't know. Okay, now that angle is 14.25. This angle is 90. This angle is 90. This angle is 14.25. So what does this angle here have to be? The Da Vinci Code. I don't know why that was so difficult. Okay, and one more thing I want to add in this problem is this is the symbol for similar. Similar figures of, you can set up the proportion and cross multiply. This is the symbol for congruent, which means that they're exactly the same shape and size also. So this is same shape, one big, one little. This is same exact shape and size. It's a squiggle with an equals underneath. Not my best word. All right, we have one more problem. And it is going to be take longer to draw than it is going to be to do the problem. in here. I would love to spend a couple of minutes getting you set up on the first digital escape problem if we could. I had fun drawing these this weekend. I got flare pen all over my hands. It was great. I'm pretty sure if they ever find out that flare pen causes cancer, I'm done for. I don't know. Hmm? It says Papermate flare. They're like felt tip markers, basically. Okay, now the only thing we're going to do for this problem is write what's called a congruency statement. Congruency statement does two things. It says that shapes are exactly the same shape and size, and it lines up the letters. Okay, so this is the symbol for triangle. Yeah, I know. Crazy. Okay, I'm going to go in alphabetical order on the first triangle. So I'm going to go M and P. And then I write is congruent to triangle. So triangle MNP is congruent to triangle. Okay, now this is really, really important. You have to write the letters in the second triangle in the same order that the first triangle is written in. So what I mean by that is I started with angle M, right? Do you see that M is between the 8 and the 20? So I have to start on this side with the same one that it's between the 8 and the 20, which is U. Okay, then I went to N, which is between the 20 and the 16. So which one is that on this triangle? W. Okay, and then V is last. On a congruency statement, we have to be really careful on the second triangle to make sure the letters line up in the same way as the first triangle. The first triangle, you can do anything you want. The second triangle has to line up with that. Okay, now, can you find the page in your packet for the digital escape, please? I know we only have a couple of minutes left. I just want to get you started on it so that you don't get home and you have like a blank piece of paper. I don't want that. So find this. I wrote similar figures at the top. You're going to have to write that part. Okay. All right, here's the first one. Okay, now this one is labeled in such a way that we do not need to draw them separately. Okay, do you see the height of the little triangle? What's the height of the little triangle? X plus 2. Okay, so on my paper, I wrote X plus 2 over. Okay, what's the height of the big triangle? 8. Do you see it? Okay, so I'm going to put that over 8 equals, what's the base of the little triangle? X plus 1 over 6. So height over height equals base over base. And again, you can set that up a bunch of different ways. Just be consistent. Okay, I just rushed through that. Did you guys get two?
Yeah.
Okay, now let's go back and look at the code real quick. I'm just trying to rush. Okay, so the code says the first letter in the code is X. Okay, so look over here. X was 2, so it's H. Okay, the second letter in the code is CD. CD is from here to here, which is what? X plus 2, which is 2 plus 2, which is 4, which is A. Second letter is A. Are you with me? Do you see what we're doing here? Okay. Third letter is DE, which is 2 plus 1, which is 3, which is D. And 4 is CE. Okay. What do you have to do to get that? Pythagorean theorem. Okay, so what was it? 4 and 3? So you've got something like this. Do you see what I mean? Okay.